Hello, I am Mohammad Siddiq Khan and today our team is going to present on a topic blood glucose monitoring. So let's start by the introduction part. Monitoring blood glucose is essential for managing diabetes and related conditions that impact blood sugar levels. Regular blood glucose monitoring empower individuals with diabetes to make informed decisions about medication, diet and lifestyle, helping them maintain blood glucose within a target range and prevent complications. It involves measuring the concentration of glucose in the blood to assess how well the body is regulating the blood sugar level. And then we have our research objective. Firstly, we will model the blood glucose level of a diabetic patient after meal with various parameters like physical condition of the patient and nutrient present in the food. Then we will develop a correlation between the after meal glucose level and the independent parameter by applying the various ML model on our dataset. Then on third point, we have the optimal insulin dosage study, where we aim to investigate the impact of insulin dosage on post-meal glucose level and determine the optimal insulin dosage for effective glucose control. Then lastly, we will identify the optimal meal nutrient intake by comparing the person with and without medication. So for research objective 1, we will develop a model of a person after meal, and for modeling we have presented a comprehensive evaluation of our proposed system with a number of traditional machine learning techniques and a detailed analysis of the result. For our study we will have our independent variable as physical characteristic of an individual, which are basic like height, weight, gender, age, family histories, etc. And then the food intakes like carbohydrate content, glycemic load, protein, calories, fiber and fat. Then we will have exercise duration, medication dosage and blood glucose before taking the meal. And then we have our dependent variable in the model as blood glucose 2 hours after taking the meal. For the assessment of our model, we have split the full dataset into 70% for the training purpose and 30% for testing purpose. Moving on to model selection, we explore three different algorithms: linear regression, random forest, gradient boosting regression, where each model offers unique advantage and techniques for predicting outcomes. Basically, this is the code of our ML model, which is written in Python. We will share the link of the Jupyter notebook in the description of this video. Then we have result part. Now after applying all this model, we have our result as such, where the coefficient of determination, root mean squared error and mean absolute error for all the three model have been given: linear regression, random forest and gradient booster. The coefficient of determination value comes out best in gradient booster model as 0.62. And also we have the graph which shows the relation between the predicted and actual value. In the graph, the dots are represented the actual value of blood glucose and red line represent the relation between the actual and predicted value. The line we have got from the linear regression model. Now Nilay will explain you further.
Okay, so basically this is the equation which we have developed through the linear regression model, and this is representing the relationship of blood glucose after with the different parameters. Here 408.895 is our intercept and the rest of the numbers are our coefficients according to the different kind of parameters. For the random forest model which we have applied previously, we tried on various kind of parameters, and the best parameter set on which we are getting the most optimized value for random forest is this. For this we have applied the grid search CV, which I'm going to show in the Jupyter notebook. So here is this. We have taken different set of parameters for every entry, and that we apply grid search on this, and finally we get the best set of parameters like this. And we calculate our R2 score for these set of parameters, for which we get the R2 score value as 0.61. Now we come to our research objective 2, which is developing the correlation metrics. We are developing the correlation metrics because we want to know that how the blood glucose level is changing with different kind of parameters, and which parameters affecting the blood glucose level most significantly. By applying the correlation metrics in our Jupyter notebook, we come to the conclusion that the profile features of the person, which are the age, weight, and the diabetes duration, the family history of the person, and the medication features, the medicines which the person is taking, they are displaying the strong relationship with the blood glucose level, and this we are expecting already. The other parameters like the height, the exercise duration, the meal rich in carbohydrates, especially in carbohydrates because they got converted into sugar and they will affect the blood glucose level more significantly. The parameters like the protein, calories, higher glycemic load, they have moderate relationship with the blood glucose level. And the meal which is rich in fat, fiber, and which have low GL, they are not affecting the blood glucose level that much because definitely fat fibers, they are not going to convert in the sugar. So our results for the research objective 2 is as follows. This is the correlation heat map which we have developed. Through this correlation heat map, we can get the correlation between any two parameters. But to be specific, our parameters, our dependence with the PG after with other parameters is as follows. So these are the correlation coefficient between the PG after and the other parameters. By analyzing these correlation coefficient, we can verify that which parameters are having significant correlation and which are having moderate or weak correlation with the PG after. So the result which we obtain from the by seeing the correlation matrix is that increasing height and weight is going to lower the blood glucose level. Although from various resources, we get to know that height and weight should increase the blood glucose level. But since there are many other parameters also in our data set which have higher correlation coefficient than what is present for the height and weight, so that's why blood glucose level is not getting positive correlation with height and weight, it is getting negative correlation. So this is what we are thinking. This is what is our opinion on this. And age has definitely a significant impact. The correlation coefficient of age is 0.633, which is quite high, and which is what we were expecting that increasing age will cause rise in the blood glucose level. And regular exercise is going to improve the insulin sensitivity and it will help to regulate the blood glucose levels. So these are the results which we are getting from our correlation matrix by seeing our correlation matrix. But definitely these are quite common. Then we come to our research objective 3, which is optimal insulin dosage study. So we want to find that what should be the optimum amount of insulin which we should give to a person so that the blood glucose level of the person remains maintained. So basically, we have developed a linear correlation as we have already described in our previous equation, this one. And we can use this equation to find the optimal amount of insulin which we should give to the person so that the blood glucose level is maintained. Since it's a general correlation, we can't be very specific because different persons have different kind of parameters, different kind of diets, and definitely they will have different requirement of insulin dosage for maintaining the blood glucose. But we can prove this with the help of an example, which we have shown here. So basically, we have taken a person. The characteristics of the person are as follows. The person is male and 160 meters the height and etc etc. The person is quite old, 82 years the age, and the person is not doing the exercise in our case. The nutrient details of the person is 43 gram CHO, 14 gram protein, and this is what is already given. And the initial blood glucose level of the person is 126 mg per deciliter. For this person, we applied our equation and we try to find the optimal amount of insulin, which I am going to show further. First of all, what should be the optimal blood glucose concentration which we want? The concentration should be between 70 mg per deciliter to 100 mg per deciliter. At this concentration, the blood glucose concentration of the person is normal. Between 100 to 125, the patient is considered as pre-diabetic. So this is the amount of diabetes. This is the concentration when the person is going to enter the diabetes. So for our case, we have taken 125 mg per deciliter as our optimum value. And now we calculate for this value, and what we get is that 15 mg per deciliter is the optimum amount of insulin dosage which we should give to the person to maintain his blood glucose level. We just put the parameters in our equation and we can find it. So this is the practical use, and definitely for different persons it is going to vary. Then we have our fourth research objective, which is the optimize diabetes management strategies. Mainly we are going to find the amount of nutrients which we should take to maintain the blood glucose level, and specific we are going to talk about the carbohydrates. So in this case, we try to take two type of cases. First, when the person is not taking the insulin, and the second case when the person is taking the insulin. We try to perform this experiment on the same person so that we can compare the results easily and we can get a better understanding of the amount of the effect of insulin. So these are the details of the person. This time we have taken the female patient, and again the patient is aged 72 years, and the person is not doing the exercise. So in one case we are giving the dosage of 8 mg per deciliter to the person, and in the other case we are not providing any dosage. So what is the result which we are getting from this? So basically, the optimal amount of glucose again we are setting as 125 mg per deciliter, and when we try to find for it by applying the same linear regression equation, the without taking the insulin, the person can take 31.4 gram of carbohydrates, and on taking the insulin, the person can take 58.29 gram of carbohydrates. This is quite obvious. If the person is eating more carbohydrates, if he is eating more sugar, he has to take the insulin to maintain his blood glucose level, which is 8 gram per deciliter, 8 mg per deciliter in our case. We also try to find the real world example of food which the person can take to complete this much amount of carbohydrate. That is, the person can eat banana, but after eating banana, the person has to take insulin if he has the given characteristics above. And if the person is eating apple, he does not need to take the insulin. This is what we are getting from the linear regression model. The other nutrients of food in this study we can take like this, but majorly the carbohydrate is going to affect the the blood glucose level of the patient, of the person. What are the learnings which we are getting from this project? The first one is the blood glucose monitoring. We collect a lot of data and we take various kind of parameters, and we try to find the variation of blood glucose in the patient's body for different sets of parameters for a different kind of persons for different kind of foods. And then we apply machine learning models on our data set, through which we get to know the variation, the R square values, and which model is best fitting our given data set. And then interdisciplinary approach. Basically, we also try to apply hyperparameter tuning to find that the model is working best on which kind of a data set. And technical and team work is definitely which we learned from this project. Thank you very much for your time.